In the beginning, God created the heavens and the earth. The earth was without form and void, and darkness was over the face of the deep. And the Spirit of God was hovering over the face of the waters. 60 seconds. And God said, "Let there be light," and there was light. The elevator doors open slowly. Fluorescent bulbs glow and a bright green door stands before you. Inside the door lies the most advanced machine ever built by mankind. And God said, "Let there be lights in the expanse of the heavens to separate the day from the night, and let them be for signs and for seasons and for days and years. And let them be lights in the expanse of the heavens to give light upon the earth." And it was so. Buried beneath Switzerland and France at a depth of 574 feet, the Large Hadron Collider hurls particles at each other at speeds 99.9991 the speed of light in an underground track 17 miles long, built to rewind creation to a trillionth of a second after everything began. And God said, "Let there be an expanse in the midst of the waters, and let it separate the waters from the heavens." And God said, "Let the waters under the heavens be gathered together into one place, and let the dry land appear." And it was so. God called the dry land earth, and the waters that were gathered together he called seas. And God saw that it was good. Magnets guide the particles towards each other, bending them, steering them away from their natural state, a straight line, aiming them at each other. And God said, "Let the earth sprout vegetation, plants yielding seed, and fruit trees bearing fruit in which is their seed, each according to its kind on the earth." And it was so. Colder than deep space, these particles screamed through a vacuum at opposite ends, racing around the circle, gaining energy with every lap. And God made the beasts of the earth according to their kinds, and the livestock according to their kinds, and everything that creeps on the ground according to its kind. And God saw that it was good. After hours building energy, the particles are guided into each other, causing violence and destruction beyond anything nature produces on earth. Then God said, "Let us make man in our image, after our likeness." And God saw everything that he had made, and behold, it was very good. Thus the heavens and the earth were finished, and all the host of them. And on the seventh day, God finished his work that he had done, and he rested from all his work that he had done in creation. And in that microscopic man-made destruction, something extraordinary happens. Energy transforms into matter. Time itself begins to slow, and particles that have not existed since the first heartbeat of the universe suddenly flash into being. Welcome to Rebel Road. I'm Mary.
And I'm Haley. Hello, everyone. We are so happy to be with you all today. Spring is in the air. The flowers are starting to bloom. The skies are still blue. Tornado season's kicking off. And 4,300 miles away in Switzerland, 574 miles below the Earth, there's a giant racetrack, and it's hurling protons at each other in really the most dangerous game of chicken ever.
But is it chicken if they want them to crash into each other, Haley?
You know, I'm not sure, but it's definitely the craziest game of crash test protons.
No, I get where you're going, poor protons. But yes, welcome back, friends. We hope you enjoyed our last episodes, and especially that one with George Lunsford. What a guy. We had so mumuch fun hanging out with him, and we are always looking for guests. So email us at rebelroadguests@gmail.com, and you could be on the Rebel Road podcast. But much like going on a road trip with no GPS or map, you just never know where the Rebel Road podcast is going. And today, if you haven't guessed it from our opening story, we are here to chat about CERN.
And Mary, if our listeners, if they're from conspiracy land, then they know a little bit about CERN and are concerned about CERN. You see what I did there, Mary?
Haley, you never disappoint me with those dad jokes, and I'm a little concerned about your humor sometimes.
Well, I think that'll make two of us, honestly, but I think I'm a delight. But Mary, what would happen if someone were to somehow steal that Large Hadron Collider at CERN?
Well, I really don't think that they could, Haley.
I know, but hypothetically speaking, well, if they did, think about the matter of great concern.
Stop.
Okay, one more. I just got to give it to you, Mary. What happened when they put rum and pineapple in the particle accelerator?
I have no idea.
They discovered a pina collider.
Oh my God. I could use a pina colada after these jokes. But okay, how about this one? Do you know what the ducks in CERN say, Haley?
I do not. What do they say?
Quark, quark.
Think that tops my other dad joke, so I'm going to let you have that one. But, I think we're just pumping up our listeners with some awesome jokes. Feel free, friends, to retell those gems. And by the way, laughter is always a good thing, especially before we get into all the science and theories of CERN. But I am really excited to talk about CERN today and to just get into it. Now, most people probably have heard of CERN, but they might not know exactly what CERN is. And, as Mary and I like to do, we like to talk about the details and the science because those are always the foundation of understanding when there's news and coverage and it's always in our face. Let's start understanding that it's really the devil in the details, right, Mary? So let's start. What is CERN?
Excellent starting place, Haley. And CERN. Well, CERN is the European Organization for Nuclear Research, the world's leading laboratory for particle physics. It's located on the Franco-Swiss border near Geneva, so it's in Switzerland and France. And CERN gets its name from the French acronym for, and I'm going to butcher this, I apologize, but Conseil Européen pour la Recherche Nucléaire. So the European Council for Nuclear Research. And it was established in 1952. So it is a French acronym. And yes, CERN was established way back there in 1952. So CERN is the acronym in French, the Conseil Européen pour la Recherche Nucléaire. So it's been around a lot longer than most people realize. And what CERN is trying to do, it wants to understand how the world we live in was made. They are trying to capture the Big Bang seconds after it happened. But we know how it all started. We know, and it was God. And Hebrews 11:3 says, by faith we understand that the universe was created by the word of God, so that what is seen was not made of the things that are visible. I just wanted to pop that in there for our listeners.
A nice little plug and reference back to the Bible. Also, Mary, I think, your French accent is pretty good. I think we're ready to just go ahead and book a trip. You can,
Oui, oui.
yeah, just get us around the country. But back to CERN. It is a scientific research facility, but not like one really big building with offices, though it does have that. CERN is so much more, and it's in the news. It's in social media. It causes all sorts of different news and theories. because it is also where that Large Hadron Collider is located. We mentioned that in our opening, but in case you missed it, the Large Hadron Collider, or the LHC, it's 17 miles in circumference. It's 12 and a half feet wide inside, and it's located 574 feet underground. Now, CERN operates a massive research complex, and it's really spanning approximately 1,532 acres across that French-Swiss border. And this infrastructure, it includes over 670 buildings, over 43 miles of underground tunnels, and just under 19 miles of roads. Now, CERN is a city within a city, and it's dedicated to particle physics research. And this facility has thousands of scientists spanning over 100 different countries that are working there at CERN.
Yeah, CERN is really a big deal. It's not just some scientific lab in Switzerland. It is massive. It's a heavily secure facility. They use multi-layered security completed with gated entry points, their own security force, key cards, access points, biometric security for high security access areas, authentication codes, and even airlocks. So even though they are opening up tours according to their website for 2026, you cannot just roll up on CERN. That is never going to happen.
Yeah, and to go along with the security at CERN, it's important to realize that CERN is an intergovernmental organization with 25 member states, really functioning with a high degree of autonomy and immunity from national legal processes. And what does that mean? Well, it means that it operates under a special legal status that places it largely outside of the direct jurisdiction of national laws regarding its internal operations, research, and safety standards. So when you think about that, it basically means that CERN has zero accountability to the world.
And that is just insanity. Just think about this. They are working on a subatomic level, doing things that they don't even quite understand just to test theories. And in 2008, a group of scientists and activists actually filed lawsuits in various jurisdictions, including one from Hawaii. They were attempting to halt the LHC from coming online. They argued that the LHC's high energy particle collisions could create catastrophic phenomena that would destroy the Earth, such as black holes that could swallow the Earth, strangelets that could produce strange matter, and that would convert the entire Earth into a dense, dead lump, and then even magnetic monopoles. And they suggested that those could cause a chain reaction leading to proton decay. But these cases were all dismissed as having no scientific basis. Now, the plaintiffs, they used the National Environmental Policy Act, the NEPA, as their primary legal tool. And they argued that the U.S. government, via the Department of Energy and National Science Foundation and Fermilab, had failed to provide an adequate environmental impact statement for its participation in the project. And they wanted a restraining order issued to stop the U.S. agencies from providing components or funding to CERN until there were more safety studies conducted there. But on September 26th, in 2008, District Judge Helen Gilmore dismissed the case, primarily on the following grounds. She said that there was a lack of jurisdiction. The judge ruled that the court had no authority over CERN, an international organization based over there in Europe, and the U.S. financially, their role with CERN was not enough. So the U.S. invested $531 million, and that was deemed a small fraction because CERN's total project budget was over $8 billion. So that meant it didn't constitute a major federal action that would trigger an EPA requirements. Now, they also said that the court said that They found the plaintiffs had failed to provide credible threat of harm, describing their fears as speculative. So, in short, even though members of the scientific community have been very vocal, even Stephen Hawking was said to be against CERN. CERN continues to operate. It operates outside of government or law because it is a multinational private facility. Just make it make sense. But CERN does have a tripartite agreement with itself, France, and Switzerland regarding some environmental safety, radiation protection, and non-radiological impacts, with oversights from the French Nuclear Safety Authority and the Swiss Federal Office of Public Health. So they have a little guidance or governance in those areas. But the people that live there in that Swiss French area, people live directly over that LHC, and they just go about their life not really knowing what's happening underneath them from day to day.
Yeah, but let's think about that. People were so concerned, they tried to stop the LHC from coming online. And we have to ask why. Well, if our listeners are still with us, we're going to get there. And Mary, kind of like Granny would say, you can't enjoy your dessert until you eat your veggies. So let's understand the science before we get to that broader picture. Now, we aren't saying that they're doing things willy-nilly there. We have to remember that these are top-notch scientists, really at the top of their field with massive budgets. And let's think about that. Most people can't validate the data they put out. And I'm not a physicist or an engineer. And Mary, no offense, but I don't think you are either.
Not even close.
So even though CERN, they do release their findings regularly, they have an open science policy. We kind of have to take their word for it on things. We just accept their explanations. And this creates a big gap between what we can test and verify versus what we are told. And CERN is masterful at downplaying incidents and calming fears. And fears from the public, they're there. So much so that CERN had to add a specific FAQ page to their website. And these are questions from social media. And let me just read a few of these. These are straight from the official CERN websites. Go to CERN's website. You'll see a lot more than these. But again, straight from their website, I'm going to read these. The first question: will CERN generate a black hole? And what was their response? The LHC will not generate black holes in the cosmological sense. However, some theories suggest that the formation of tiny quantum black holes may be possible. The observation of such an event would be thrilling in terms of our understanding of the universe and would be perfectly safe. Okay, I don't know. Does that sound safe? But let's get to the next question, straight from the CERN website. Is the Large Hadron Collider dangerous? And CERN's response: no. Although powerful for an accelerator, the energy reached in the Large Hadron Collider, LHC, is modest by nature's standards. Cosmic rays, particles produced by events in outer space, collide with particles in the Earth's atmosphere at much greater energies than those of the LHC. These cosmic rays have been bombarding the Earth's atmosphere as well as other astronomical bodies since these bodies were formed, with no harmful consequences. These planets and stars have stayed intact despite these higher energy collisions over billions of years. Now, we're going to touch on that energy that CERN generates here in just a little. And so pocket this response here from CERN. One more question I'm going to read straight from CERN's website. Will CERN open a door to another dimension? Yes, friends, this is a question on CERN's website. And CERN's response to that: CERN will not open a door to another dimension. If the experiments conducted at the LHC demonstrate the existence of certain particles, it could help physicists to test various theories about nature and our universe, such as the presence of extra dimensions.
That doesn't sound like a no, but kind of like a redirect, in my opinion.
Exactly, right? Now, if you go on their website, again, there are more questions and answers, and we will link this in our show notes like we always do. But they address most of the conspiracies, such as having a statue of Shiva and their logo, and many see that as 666.
They really are working very hard to maintain a very scientific and safe reputation with the world. But again, most of us can't really comprehend what it is they are actually doing. I mean, I had zero idea before I started with this research on what the LHC even was.
Well, let's try to explain what is happening in the LHC. What exactly is a Large Hadron Collider? What does it do? And why did they create one?
Okay, well, now, everybody, we're going to have to put our thinking hats on and we're going to have to go deep into some science here. We described it in the opening, but let's do it one more time. Picture a 17-mile wide racetrack. Now, for my NASCAR friends, hey, Gail, hey, Tiffany, Talladega is the biggest track in NASCAR, but it's only 2.66 miles long. Now, the LHC is 17 miles around. So imagine a giant racetrack built 574 feet underground, encased in a 12.5-foot concrete lined tunnel. And when I say track, I mean metal tubes. There are two tubes in the LHC. These tubes are mostly made of stainless steel, aluminum, and beryllium at the intersection points. Now, to contain the magnetic field needed to control the protons used in their experiments, it had to be underground. The magnetic field that the LHC generates, that is what guides the science. These magnets are the most powerful superconducting magnets in the world. Now, superconducting describes a state of matter where certain materials, when cooled below a specific temperature, conduct electricity with zero resistance and expel magnetic fields. So, absolutely no heat. This means electric current flows indefinitely without losing energy. It is a quantum mechanical phenomenon, superconducting, and CERN uses a large scale cryogenic system that uses liquid helium to help keep the superconductor magnets functioning. Now, the LHC, when powered on, this system maintains a negative 456.3 degrees Fahrenheit. Now, that's colder than deep space.
I want to make sure I heard you correctly. Negative 456.3. I just want to make sure I heard that right.
Yeah, negative 456.3 degrees. They keep this track at that temperature. These magnets use superconducting coils made of niobium titanium, and there's thousands of miles of this expensive wire. Not only that, these superconducting filaments are clad in high purity copper for stabilization. The engineering of CERN is incredible. But, we're not done yet. We're just trying to explain the machine. There are over 9,000 magnets in the LHC, and that magnetic field that they create is measured to be 8.33 to 8.36 Tesla. Now, I really had to look into that because it sounded powerful, but it is beyond powerful. Think Magneto and X-Men. Haley, how strong do you think the Earth's magnetic field is? More or less than CERN?
Well, I would say more, but the fact that you're asking, I'm going to change that answer to less. And I have to say, I get the visual with Magneto, but as always, your comic nerd is showing a little bit.
Well, I like to squeeze a little comic book charm in there when I can, but let's take a look. You are correct. Earth's magnetic field is 0.25 to 0.65 Gauss. So magnetic fields are measured in two weird words, Teslas and Gauss. Who knew? Now you learned something. But the magnetic field inside the Large Hadron Collider is over 100,000 to 150,000 times stronger than the Earth's magnetic field. That is the 8.33 to 8.36 Tesla. So a Tesla is much stronger than a Gauss. So an MRI actually is stronger than the Earth's field as well. It is a 1.5 to 3 Teslas. So think about all the rules and safety they need when working with an MRI. You can't have metal, they take all these precautions. So it is a no wonder that they needed to build this thing so deep under the ground.
So, Mary, I asked Google, what if that strong of a magnetic field was unchecked? And here are a few things that would happen. If a field of this magnitude was unleashed and left uncontrolled, such as created by CERN, the effects would include, and I'm going to summarize these the best that I can, extreme physical and structural damage. Now, what does that look like? We are talking ferromagnetic projectiles, and a ferromagnetic material, think iron, steel, cobalt, nickel, within a certain range would be immediately pulled towards the source with tremendous acceleration. And that really is turning those items into lethal projectiles. And then after, structural failures. Now, again, strong, unchecked fields could apply massive lateral forces on skyscrapers and large infrastructures containing steel. It would really lead to structural failures. Now, that kind of plays into, Mary, your magneto theory and image that you shared. And molten metal and fire. The rapid movement of conducting materials within the field would induce high voltage currents, and it would cause the metal objects to heat up, spark, and potentially melt. Intense auras and heat. The field would trap charged particles, potentially creating permanent, intense auroras and increasing local radiation with heat levels. Now, we've seen some crazy auroras lately, but is that CERN or HARP? Think about that. Interactions with nervous systems. Biological nervous systems, which rely on electrical signaling, would likely be disrupted, causing pain or disorientation to animals and humans near the field. And a couple more. Devastation of animal navigation. Many animals, such as the migratory birds, bees, and sea turtles, they rely on biological receptors and magnetic fields. A massive localized field would cause them to become lost, and it would really threaten their survival. And not to mention the technological and electrical disruptions. But the magnetic fields at CERN, they're confined to the iron yoke of the magnets. The entire LHC is located roughly 100 meters underground, and that makes it physically impossible for this field to impact the surface under normal or even mini failure scenarios. Now, these fields are contained within the accelerator, and they drop off by the inverse cube of the distance. And it kind of makes them undetectable at ground level directly above them. So now we know exactly why the LHC is so far underground. And I do wonder how, Mary, let's think about this. I wonder how the Hollow Earth people are doing in that area.
Right? I don't know that they did the math for, if we make a magnetic field this strong, how deep do we have to be underground in this rocky terrain to prevent it from causing catastrophe up above? But I don't think they did the same for those Hollow Earth people. So hopefully they're doing all right down there. But that gigantic magnetic field, it's safe. So all those things that Haley said, so that magnetic field, it's absolutely safe and secure due to it being underground. But let's keep going with these magnets. These magnets are just crazy. These magnets are what bend or steer the particles, and they are called dipoles. And these magnets are almost 50 feet long each and weigh 38 tons each. And there are 1,232 of these main dipoles. Now, these aren't tiny refrigerator magnets holding up your kiddo's artwork. These magnets are magneto, pulling all the metal to them, creating that field, just like you said in our if the field escaped scenario. But thanks to the deep conditions, we don't have to worry about that. They really are contained in these tubes underground.
Mary, you mentioned earlier there are 9,000 magnets in the LHC, and there are only 1,232 of those giant dipoles that steer the particles. What other magnets are in there?
Well, there are a lot of different other magnets, and we're just talking about the big giant ones. There are also quadrupole magnets, and these are the focusing magnets. There's over 392 quadrupole magnets, and these are roughly 16 to 23 feet long, and they're used to focus the beam to a fine point, ensuring that they collide at specific intersection points. So, as these particles are launched into the LHC, one beam in each tube. So one goes clockwise and one goes counterclockwise. And these beams are guided every step of the way with this magnetic field. And if the magnets weren't there, these particles would just shoot into a straight line in their natural state. Nothing would happen. Protons move in a straight line naturally, and they would just go through the walls and into the ground or whatever. But the magnetic field guides the protons. And the quadrupole magnets, these focusing magnets are in the detectors of the LHC. And this is where they capture all that data. This is where they get those beams to intersect. And at these 4 detector sites, and there's only 4 that we are told about, each site has a name. So we have Alice, Atlas, LHCb, and CMS. So, in my brain, if there's an LHCb, where's LHCa? But that's just me. So, thinking that they could have a secret focusing area there because there are 43 miles of underground tunnels, but the LHC is only 17 miles round. And that's just me. But, um, you know, these detector sites, they're like different labs. They each have their own thing that they're looking for, and they all look a little bit different. And these labs, they're not like a little room or a little box. These things are ginormous. I can't remember which one, but one of them weighs something like 38 tons alone. They're ginormous detector areas. But the dipoles and quadrupole magnets and other magnets, these magnets allow the LHC to achieve unprecedented energies by forcing particles to navigate turns at near light speeds. And these particles, the two opposite beams, they fly around this 17-mile track. Think about this. They do 11,245 laps of 17-mile track in just 1 second. So they go around 17 miles, 11,245 times in just 1 second. That's mind boggling. But they keep this speed and they build up energy as they circle around the track, squeezing the beams with the magnetic field and concentrating them to be as narrow as possible at the intersection points within these detectors. So they do this for like 12 to 18 hours. These protons are just in these tubes shooting around until the beams are narrowed and aimed at each other. So this is kinetic energy. This is motion. Remember, absolutely, there's no resistance. We are at colder than deep space when this is happening. So there's no friction from this energy that they're building. And so once these beams have been racing around for whatever time they want, they open the detector magnets and then they slam these beams into each other. And these impacts generate temperatures over 100,000 times hotter than the sun's core, tearing the protons apart to produce new particles, creating a shower of new particles such as quarks and the Higgs boson. And the detectors map all of this data. And this disproves or proves the theories that the scientists at CERN were searching for.
Well, Mary, it's like a Hot Wheels crash track. And when the cars smash together, they're making smaller and different cars.
Right, sort of. This is where the science makes me feel really, really dumb. So the protons are a form of particle from the hadron family. Thus, we get the Large Hadron Collider. And protons are subatomic particles composed of fundamental particles called quarks and gluons. Remember, quark. One protein carries three quarks, and the gluon is the invisible force that holds the quarks together. But beyond the three valence quarks, a proton is a dynamic sea of transient quarks, antiquarks, and gluons. So these forced collisions, they break all of this down further.
So, what are these protons to begin with?
That all start off as hydrogen protons, the same gas that feeds the stars and floats in the air we breathe. An electric field strips the electrons from the hydrogen, and they have their isolated hydrogen protons.
So, going so fast, 99.9% the speed of light, that results in time dilation, right?
Yeah, it does. So the protons in the Large Hadron Collider experience significant time dilation due to traveling at 99.9991% of the speed of light, causing time for them to pass roughly 7,000 times slower than in the lab frame. So basically, time stops for the protons, and consequently, unstable particles produced in collisions survive for thousands of times longer from our perspective than they would if they were at rest. And this is what allows the scientists to capture the data,
Well, I don't know. For me, it seems that that would translate into time travel.
right? It kind of does, but not really. You know, if we were protons, the Large Hadron Collider would act as our time traveling machine, propelling us close to the speed of light. And as we accelerate through the collider's magnetic fields, time would slow for us. And thanks to Einstein's theory of relativity, every second passing outside, we'd experience just a fraction of it. So while we wouldn't physically travel to different areas, the extreme relativistic effects would make time itself behave differently, allowing us to experience a slower version of reality as we race through the LHC circular tunnel at unimaginable speeds. So time would pass outside of us, and we would just be kind of sitting outside of time,
But we would kind of live outside of time or beyond reality.
right? It gives us a headache. I know. I don't really know exactly what that means. I do know, and I just found this out, and I'm going to explain it wrong, but there was an incident in 2025 at the LHC that they can't explain, where most scientific theories, it's cause and effect. Something happens and then boom, this happens. They lost 3.121 seconds of time in their LHC experiment, and it is freaking them out. They don't really know what happened, and everything is checking out. So that will be interesting to see how they explain what happened there. But yeah,
Yeah.
they're messing with time.
Yeah. Well, just what you said. Ultimately, though, they are messing with time, obviously. And there's some conspiracy theories claiming that these high energy collisions have altered the fabric of reality or shifted our universe into a parallel dimension. Because of that, resulting in those Mandela effects. And what is a Mandela effect? It's large groups of people seemingly sharing false memories. Now, Max Laughlin, who is a 13-year-old genius who studied the papers released by CERN, again, remember, he's a 13-year-old genius. Now, he claimed, and he said it was a theory, but he theorized that CERN destroyed our timeline and shifted us into a parallel timeline, thus those Mandela effects. Now, his videos went viral back in 2016 when he released his claims. And after that, he vanished. I mean, this kid was a genius. No one disputes that. But where did he go? And we had to dig to find this, but let's listen to Max explaining a little bit about his theories.
Focus more here on these lines. In our multiverse, and there's an infinite number of these realities, and in each reality, as every electron spins an animator of an animator to an animator to an animator around a nuclei of an atom, we're catapulted into a million not a million, an infinite number of alternate universes. Just imagine this is the start of the universe. This is our original timeline, right? But as soon as this starts, we are infinitely catapulted into an infinite number of parallel universes. And somewhere infinity down the line, here's our universe, right? And then we're constantly shifting into alternate universes as we speak. And that expansion of infinite universes is our reality as we know it in time. So therefore, if there are other universes, they're next to ours. And this actually relates to my theory of the Mandela effect and how the particle accelerator altered the weight of one electron and therefore destroyed our universe and shifted us into the universe that's directly next to it. And therefore, things are different in this universe.
So you believe that this thing that some people call the Mandela effect is actually real?
Oh, it's absolutely real.
Can you describe what it is for people who have never heard it before?
Sure. So the Mandela effect is the effect of some people thought that Nelson Mandela died at a certain time, and other people remember it as a different time. And this goes for a lot of other things. Star Wars, classic videos, Mirror, Mirror on the Wall. Everybody knows that. Well, if you actually look back to the original film, it's not Mirror, Mirror on the Wall. It's Magic Mirror on the Wall. And some people actually...
Which, of course, it's not.
It's not.
In the reality I grew up in.
Right, exactly. And I mean, some people in this reality, I guess, maybe didn't make it from our last reality, I'm thinking. I'm still trying to figure out why they don't remember it. And some people do. But anyway, though, that is the Mandela effect, and we are living in an alternate expansion of our universes. Even in my own scientific notes, I've found rewritten signatures and things that are a little bit different from originally what I wrote.
So how did that actually happen? Let's take your notebook, or let's take Mirror, Mirror on the Wall, and like an old film, animated film. How did it actually change?
Well, it never changed. We changed. That means there's an infer, which then create more universes, which then reverse to create other universes. As I said, infinite universes, infinite everything.
Piece of the Mandela effect, and let's have at least one human being who might watch this potentially be able to understand what you're saying.
Right. So when our universe was destroyed over here...
And this was, you think, when CERN Super Collider did its experiment?
Large Hadron Collider, yeah.
Or the Hadron?
Large Hadron Collider, right.
Okay.
Our universe and timeline was destroyed.
Definitely a smart kid. He was taking classes at MIT. And remember, he's only 13. But after these videos, he absolutely instantly had no online presence, and people can't find him. And that is suspicious, much like how scientists and whistleblowers always end up dead.
A lot of that in the news right now. Now, we aren't saying Max is dead. We just think it is odd how he has just vanished. But let's talk real quick about these Mandela effects. Mary, what's one that freaks you out, or a Mandela effect that you've experienced? Have you experienced any?
Yeah, there's a lot of them. The most recent one is King Tut. I'm a big ancient history gal, and I would sit on my daddy's lap and look at those National Geographic magazines with him almost every night. And when they had Egypt, man, those were my jam. And King Tut, he had a cobra on his headdress. And that's it. It was just one cobra smack dab in the middle of his headdress. But now he has a snake and a red bird. Ain't no way he had a snake and a red bird. It was just one cobra. I will die on that hill. And another one would have to be Interview with a Vampire. I had those books. I read those books. I love those books. And when that movie was out, I was all over it. But it's not called Interview with a Vampire anymore. It's Interview with the Vampire. Again, no way. But I went and I looked and I pulled those covers out, and they say Interview with the Vampire. Freaking me out. How about you, Haley? You have any of those?
Well, you hear the basic ones, the Bernstein versus Bernstein, the Fruit of the Loom cornucopia. Now, these Mandelas, they're wild, and we absolutely want to know, our listeners, reach out. What memories do you have? And Mary, I know we kind of chatted about this. We were thinking about doing a special listener episode you guys come on and share what Mandela effects you've experienced. And if you're interested, go to our website, click the leave us a fan mail. And remember, you can send us a voice message and tell us what have you experienced when it comes to the Mandelas. But in addition to the possible destruction of one of our timelines, so I'm going to circle us back to CERN, what else is CERN doing with the LHC? What about portals, Mary? What do you think? You think they're opening portals?
Well, what kind of portals? That's like a big question. Interdimensional, I think that they absolutely could be. They are looking for different dimensions. And we have access to 4 dimensions. We have length, width, height, and time. And for string theory to work, we need 10 or 11 dimensions. And I think the 5th dimension is what they are currently trying to find. So it's a plane of probability showing branching alternative timelines. That's what the 5th dimension is. So it sounds like a ripple or a Mandela, but CERN actively states that they are looking for those other dimensions with the LHC. So scientists look for evidence of extra dimensions by searching for missing energy in particle collisions. So, when they're smashing them together. And when the particles disappear, that indicates to them that the particles, such as a graviton, could have escaped into a hidden dimension. So they say they're not trying to open a portal, but rather to understand the laws of physics, and to understand something, they need to study it. And you can only study something with observation. So if they want to know about portals, they have to be able to open portals in order to observe them, right? They've recently found particles that they can't explain, much like that 3 seconds that was there for some reason. Heavier particles, now those that they've just found, these are heavier particles. Now, those could be new to our dimension, or they could be something that has crossed into our dimension from another dimension. Does that make sense?
Yeah. Now, all of this is done on subatomic levels, right? So people aren't going through portals to new dimensions. Things aren't coming here.
Or, that's what they claim. But if they're able to do it on the microscopic subatomic level, what's stopping them from making it bigger to where people can go through and things can come in? You know what I'm saying? Like I said, there's 43 miles of tunnel, but CERN is just 17. So, what do we really know? We don't know. I've heard stories of gateways and portals deeper in CERN that involve teams going through them and things coming out of them. And these stories were from people who seem to have acknowledged some crazy things. And we have Dr. Astrid Stuckelberger, who in 2022 said these very things. Now, let's listen to a few of her words.
Right. Just giving it a second on that. It's giving Stranger Things vibes.
Yeah. CERN's total Stranger Things.
Yes. CERN is total Stranger Things.
There are beings from portals coming in and out. It's physicists from the CERN who told me this.
They've testified to beings coming in and out of portals.
Yes. They have, apparently, in the bottom of the CERN, this portal, this door where they are dealing with all the subatomic dimensions. They say there are 17 different dimensions of reality. That's what those physicists say. Some others say there are more dimensions, And now, when you look at what is going on in the CERN, there is a fight from some of the military agencies, intel. They say that there is a fight on time. They're trying to change time. There's a door, a round door, like in the Stargate. And I don't know if it's as big. There is one picture that the person is quite small, actually. You can go and look for those interested. Go and type CERN portal LHC door, and you will see. So in front of the door, they have a room. They probably have many doors, but they have a room, and they sit around the table. And I said, so yeah, what happened? He said, well, an entity came from this portal, and like sat at the table. I was like, but how is this what do you mean entity? Is it a person? Is it an alien? What color? Are they like us? And they couldn't answer anything. They said, no, it's not we know, we just know it at CERN, and they cannot describe it, but they have it secondhand. It's not third, fourth. It's a very good friend who knows. Okay, I have to find something more because that's not enough. How many dimensions officially are in the CERN? And they both said 17, very affirmatively. And then they started talking about a portal. There's a portal for the LHC. There's a round door, like in the Stargate. In front of the door, they have a room and they sit around the table. And I said, so yeah, what happened? He said, well, an entity came from this portal and like it sat at the table. And they said this entity the second time took a scarf and left a scarf. I said, what type of scarf? And they don't know. Top scientists at the Large Hadron Collider LHC says that the Titanic machine may possibly create or discover on 8th of April for the eclipse previously unimagined scientific phenomenon or unknown unknowns. For instance, an extra dimension. Who says, out of this door might come something, or we might send something through it. But that even with the power of the LHC at his disposal, he would only be able to hold it open a very tiny lapse of time. But during that infinitesimal amount of time, we would be able to peer into this open door, either by getting something out of it or sending something into it. The name comes from Cernunnos, the god of the deer, and the deer in Latin is Cernunnos, but it's an animal with horns, and that's their cult. And during the inauguration, our official politicians were standing there looking at the CERN open door with angels and demons going through it, and very crazy naked, looking naked dance.
Dr. Stuckelberger is a scientist and a researcher who works in Geneva, Switzerland, and she speaks out about hot topics like discussing UFOs, COVID-19, and of course, like you briefly heard, CERN topics. And if you have some time, go and watch some of her interviews. But beyond whistleblowers at CERN, if you look at some of the opening ceremonies that they have at CERN, honestly, folks, the symbolism is right in front of us. You have portals and things crawling out of them, this weird demonic looking goat god. And again, we'll post some of these for you all to check out in the show notes. It's just wild for a scientific facility to host such visually weird openings, at least to me.
And I agree with you. And beyond messing with time or even possibly opening portals and subatomic nuclear research, which is going on, remember, that's what it was originally founded on. CERN has created and is actively storing antimatter. Now, antimatter is a form of matter composed of antiparticles, which are twins of ordinary matter particles, electrons, protons, and neutrons, but with a reversed electric charge and opposite quantum numbers. So when antimatter touches ordinary matter, like if we touched antimatter, they immediately undergo annihilation. Oh, we just blew up, converting their total mass into pure energy. They explode. Both are destroyed. So CERN studies antimatter primarily to solve the mystery of why the universe is made almost entirely of matter, despite the Big Bang theoretically producing equal amounts of both. They want to know, where did the antimatter go? Well, we know, God. But they also wanted to test gravitation on antimatter. Some theories suggested that if it was anti, it would fall up. Gravity, if you drop something, it falls down. But CERN proved that it does, in fact, fall down. But this is a weird bit. Only 80% of the time. Super weird. 20% of the time, it does fall up. Now, antimatter, it's dangerous. Remember, when it touches matter, which is what we're mostly made of, both are destroyed. Our whole world is made of matter, the whole universe. But CERN has figured out how to make, collect, and store antimatter. That's not dangerous. Okay, keep doing that. The claim is to keep studying its properties. They are determined to understand why the universe is dominated by just matter. Again, God, but science.
Mary, on every day, my my day job, my real job, really has me wondering of my own brain capacity, and I think this tops it. But is antimatter the same as dark matter?
Good question. But no, antimatter is rare, charged mirror matter that annihilates upon contact with normal matter. Now, dark matter is an abundant, invisible substance that only interacts via gravity. And neither one of these is very well understood. But antimatter follows known physics, whereas dark matter's nature remains unknown. Now, CERN searches for dark matter, which constitutes 27% of the universe, by attempting to produce it in these high energy collisions at the LHC. Now, the experiments are looking for missing energy, and that missing energy could indicate that the particles pass through the detectors undetected. So they're releasing this dark matter somehow. So the physicists there could infer their existence from the amount of energy and momentum missing after the collision. So again, it hurts your brain. So they're able to find it by calculating exactly what was missing in the collision, but they still don't know where it went. So there's an entire page on the CERN site about dark matter and dark energy, but basically they're saying they create it and it releases somewhere. And, well, again, that just doesn't sound good. Where is that going?
Right? Okay. Okay, Mary, help me understand. There's a reason it's only 27% of the universe. In theory, what would concentrated dark matter look like? In 2025, there was a report. It did mention a potential experiment observing a dark matter bubble. So I looked it up, and research suggests that if macroscopic dark matter, think dense blobs, if that actually exists, it could technically pass through human tissue, and that would cause some significant damage. So that wouldn't be real great. But again, that's probably not super likely, but not likely. But back to antimatter, that does not sound like something you want to be making and storing. If it literally destroys matter when it comes into contact with anything, let's hope that it doesn't get unleashed, right, Mary?
Yeah, I know. And it's completely crazy. And they don't say exactly how much antimatter that they are collecting. So I am hoping it is just minuscule amounts, but we don't know. Like we said, we don't know. But in the name of science and human curiosity and the need to explain creation with something other than God, this is just a real obsession and blindness mankind has, especially CERN.
So, what about the God particle they found at CERN? Let's unpack that a little. If people have heard of CERN, they've probably heard also the mention of the God particle.
Okay. Well, first, it's the Higgs boson particle. Scientists actually hate the name God particle. They don't really like to lean on God that much. But it actually got its name from, of course, a reporter. The scientist said something to the reporter about that the Higgs boson was being goddamn hard to find particle. And I apologize. Please forgive me, Lord, for saying that. But that's what he said. He said it was a goddamn hard to find particle. And that reporter liked the sound of God particle, and that's how it happened. But basically, the Higgs boson is the theory of the invisible field that fills all of space, or the mechanism that gives mass to subatomic particles, was proposed by Peter Higgs way back in 1964, along with Francois Engelbert, Robert Brute, and other researchers. And on July 4th, 2012, that particle was found and proven true at CERN. So let's look at it. What is it exactly? Without the Higgs boson, that field, particles like electrons would just zoom around at the speed of light and atoms. And therefore, stars, planets, people, we would never form into anything. We would never collect mass. Kind of think of it like this. Imagine an invisible field that fills the entire universe like a pool of water. This is the Higgs field. And the Higgs boson is a ripple or a physical manifestation of that field or the particle, which is the boson. Now, the interaction. As other particles move through this field, they interact with it, and some particles, like quarks, get bogged down and gain a lot of mass. Others, like photons, don't interact with it at all and remain massless because it's the final piece of the standard model, and science always goes by the standard model. The Higgs boson explains how the universe's building blocks actually hold together.
So the Higgs field is like cosmic molasses and that sticks to particles to give them weight. And without it, everything would fly apart at the speed of light. And this boson part is the beginning of particles clumping together to form really everything.
Yes, that's a better analogy. So, now another fascinating fact about the Higgs boson is that it's self replicating. The Higgs boson can interact with itself, which is one of the most unique and important features. It is the only proton that can do this. It can talk to itself, it can split, it can clump to make ripples in the field, and self couple. So, a Higgs boson can spontaneously turn into two Higgs bosons just because it wants to. Now, a proton is stable and will just sit there forever. It needs something to hit it for you to get a reaction. So essentially, the Higgs boson creates.
It's literally a God particle. We've read that in 2009, there were two physicists, Holger Beck-Nielsen and then Masao Ninomaya. They proposed a wild idea called backward causation. And they suggested that the Higgs boson might be so abhorrent to nature that its creation rippled backward through time to stop itself from ever existing or from CERN to find it. And there was another theory, and it speculated that the future discovery of the Higgs was sending influence into the past to break the Large Hadron Collider, again, that LHC, before it could ever finish the job. So again, similar to a time traveler trying to stop their grandfather in the past. I don't know. I keep coming back to that time travel. But this was all because even before the LHC fired up, a number of bizarre things happened that always stopped it. There was an incident with a bird dropping some bread and it shorted out a circuit. Now, another instance, there were some weasels that chewed through the wires, not once, but twice. And then there was a freak malfunction with one of the magnets. Now, I don't know. Sounds as if God was like, maybe you shouldn't. But then was maybe thinking, you know what? You go on ahead. And boom, now we all argue about Berenstein Bears and whether the Monopoly guy wore a monocle. And yeah, I just have to say, Mary, he did.
Yes, he absolutely did wear a monocle. You're right, Haley. But it did seem like the universe did not want the LHC online. From images of weird lights in the skies over CERN and what look like portals. I mean, you can go on and you can find images of particles in the Hadron Collider, and it looks like faces are seen in the particles. And there's whispers of people going mad who are around the storage of antimatter and other paranormal events, and even scientists and missing genius theories. It's all 100% full of high strangeness and weird. CERN is definitely full of weird.
Yes, full of weird is right. And another big thing is the statue of Shiva that sits outside of CERN. Now, the response is that it was a gift from India. But again, the symbolism is a little alarming because Shiva is also known as the destroyer. Shiva destroys the universe so that a new one can be built. And if you think about it, in a way, isn't that what CERN is trying to do on some level? And then we have what appeared to be a human sacrifice on the grounds of CERN in front of that Shiva statue. And most of these videos have been scrubbed, so they're hard to find. It's hard to find the whole thing. People claim it was a sacrifice to either help open a portal or to appease something that came through. Again, CERN claims it was a bad joke and that it has handled those involved. I don't know, Mary. That seems weird. And again, Stranger Things vibes.
Yeah. These are all scientists and really smart ones to begin with. Some people do live at CERN. There are 450 rooms for staff, students, and visitors. But remember, this is a highly secure facility. So sneaking on site for a prank, that's not happening. And this level, like a human sacrifice to be a joke, that's wildly inappropriate for people who have high IQs. But, that's just my opinion. These type of people don't do those kind of weird pranks. That's what I think.
It's just distasteful. If it was a bad joke, pretty distasteful. And it's just so odd that you get these ripples of memories just changed almost every time that CERN is on. And also rumors of earthquakes caused by CERN. And again, the Mandela effects, these were first really noticed back in 2009 is when it kind of started happening. And guess when the LHC was turned on? September of 2008. And we can't say CERN is responsible for them, but we can't not say they are either. And to make you even more leery, in June 2026, CERN will shut down for 3 years of maintenance and upgrades. And then they reopen in 2029. And they're going to open up with more powerful magnets and tech. Not only that, China is building a circular electron positron collider. You can call it CEPC. And it's designed to produce millions of Higgs bosons and will be 4 times the size of CERN's LHC. And they're hoping to have that online by 2035. I'm scared.
We all should be. I mean, why would a communist country want to control and mass produce God particles? It makes you shudder a little bit on the inside. Now, according to our best friend Google, there are only 2 operational hadron colliders in the world, CERN and the one in New York. But the New York collider went offline just this year. Now, in Tennessee, there's the Oak Ridge National Laboratory, and it's home to the Spallation Neutron Source, or the SNS, which is a linear accelerator that produces pulse neutron beams. So it's not quite a hadron collider, and I thought it was a hadron collider, so I was wrong on that. But there was one in Illinois that shut down back in 2011. So there's not a lot of particle colliders in the world. So this makes them very unique.
Well, I think that's probably a good thing that there's not very many of them. Now everyone knows a little more about what they are doing over there at CERN in Switzerland and France, how they are doing it, and what an LHC is. So what do you think? Are they opening portals and messing with time? Is CERN the reason you find a freckle on your hand that wasn't there the day before? No, let us know. Let us know what you think about CERN. Dig in, do your research, check the show notes, and come back. Let us know what you find. We absolutely want to hear from you all on this.
And if you enjoyed this episode and want to hear more, please hit that subscribe button so you will never miss an episode. Share this episode with a friend, family member, or stranger. And if you listen to us on Apple Podcasts or Spotify, please hit that 5-star button or leave a kindly worded review. This just pushes us up in the algorithm and lets other weird-loving friends find us.
And don't forget, we are audio only on YouTube. It's a little weird, but it is another channel that you can listen to us on. Get on YouTube, everyone. Find our channel, look for our logo, and let's get Mary some work to do. She needs to stay busy and stop harassing me about my TikToks.
I'm not sure I agree with any of that, but okay.
All right, Mary,
Okay.
I've got just one more thing for you. A Higgs boson walks into a church.
Okay.
And the vicar says, "Sorry, we don't allow Higgs boson in here." And the Higgs boson replies, "But how else are you going to have mass?" Okay, friends, on the last glorious joke, we hope you keep it weird. And remember, when all the weird gets to be too weird, what do? We pull it back to Jesus. Until next week.
Bye.
Bye.